the stream, brother. Yeah. Okay, sorry. So, boom. My name is Menace, short for Menace Katlunga, and we're gonna do some job prep stream. I'm gonna solve some lead code. Hopefully, I'll also find some time to study for my grad algos exam. Gah, bro. Cool. So, without wasting more time, we should perhaps start solving these questions. I was just having this thought today that, uh, a, like, if you want to know if a person is well read, that person will have like a good, maybe, vocabulary. But good vocabulary is not a solid proxy for uh, knowing if a person is a good writer. I think like a reliable proxy for a good writer is their use of bigrams and trigrams. Like bigrams and trigrams like require active construction of meaning. So if you find a person using bigrams and trigrams when they are talking, it's a good indicator that they are also a writer. Like they're good writers. Like I found some really good bigrams recently, like value neutral, hype adjacent, like really cool bigrams. Anyways, that was today's random thought. Cool, so we'll solve maximum length of pair chain. Okay, cool. So let me start a timer before we start solving. Again, the goal is to get below 20 minutes. 1 2 3. This was just me creating my thumbnail for the day. So tap to unmute, and yeah, it started. Cool. You're given an array of n pairs where pair is left and right of I. Ith pair is left and right, where left is lower than right. Okay. A pair P2 equals CD follows a pair P1 AB if B is less than C. B is less than C. Sure. A chain of pairs can be formed in this fashion. Return the length longest chain which can be formed. You do not need to use up all the intervals. You can select the pairs in any order. So you can select the pairs in any order. The pairs are okay. There's 1 2, there's 2 3, there's 3 4. The longest chain is 1 2 2 3 4, which is like 2. So okay. So if there is a chain connecting, so if my end of the right of a pair connects to is the same as the left of another pair, it means that there's a pair that can be formed. Okay, makes sense. And that's essentially a link that is formed. Cool. There is also another thing example, which is there is 1 2, there's 7 8, and there is 4 and 5. So the longest chain is from 1 2 to 4 5 to 7 8. Okay, now what is not clear to me is uh, okay, so B has to be less than C. Okay, a chain of pairs can be formed in this fashion. So okay, so a pair of chain, a pair follows another pair if its right is smaller than its left. Okay, so it doesn't matter if these are continuous, they can be any uh, pair where the D is smaller than B, and then you have a pair. That makes sense. And we need to find the longest chain. Cool. I think I got the question. So now the questions to the interviewer. Cool. So I'm just gonna be like q2i 1. What is gonna be the maximum number of pairs that I get? Like len pairs. That's the first question. Uh, range of um, yeah, chain vals, and perhaps repeated pairs. Can the pairs be repeated? That's another question. The pairs can be formed in this fashion: the length of the longest chain. You do not need to use up all the given intervals. You can select pairs in any order. Okay, fair, 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 fair. Repeated pairs, can I have 1 and 2 and 1, 2 again? Is that a pair that I can have again? Because if it does exist again, then it means that I can only use one pair once. Like if even if I have a pair again, okay, whatever. We'll let the interviewer explain to us. Can a chain be empty? It cannot be. It has to have a left and right. Cool. So what does the interviewer respond with? Uh, it responds with some n. Okay. Can be anything, I guess. Okay, n can be like 1 to 1000. Okay, minus 1000 to 1000. Repeated pairs. I'm just gonna assume no because makes the job easier for me and there is nothing out there. So let's think. Let's think. If I want to form a pair, what is the easiest brute force algorithm that I can think of? I can think of, if there is A and B, uh, which is forming a pair, I can iterate through all remaining pairs and I can say, hey, uh, how many. Interesting. This is an interesting problem. It's just not just a simple brute force, but it's not just a nested loop because I have pairs in here. So a simple way, a simple brute force way would have been to keep a track of the right side of all pairs that I have so far and in a way like sort them by their right side. So for example, if I have n pairs, then I can use n log n time to sort all these pairs by their end times, like by their right number. Now what does that give me? It gives me this particular order that I have here. Okay, in this the longest chain is 1 2 say 3 4. So 2 3 is not included because it cannot be equal to. It just has to be strictly less, not equal to. So now that I've sorted it, now that I've sorted it, I try to uh, I try to iterate through the sorted array based on right side of this. Okay, so what if I actually do a normal sort, because I know the normal sort will automatically do some sort of prioritizing based on index 0 or index 1, like left or right when sorting. But okay, a let's just say I spent let's just say I spent n log n to sort this, sorry, I was getting a call. I was getting a call. I was getting a call. My bad. Give me a second. Okay, just replying to an email. Okay, and if I have 4 3 here. Sure. Okay, cool. So I know that I can do like a pair dot sort of sorts. Like this would sort this in n log n time. That would be like n log n time, and then I iterate through every pair in here, right? I iterate through every pair in here, and I know that I don't have link in the chain. I don't have to use every link in the chain. So I pick a chain. I say I pick a chain. Uh, say I go through. So this is already sorted, which is a really good thing. So I go through this and I see the first chair. I move to the next one and I keep track of what my previous link was. In my previous link, I check if this the left is greater than the previous right, and if it is, I use it in my link. If it is not, I exclude it from my link. But the thing is, it's not guaranteed that the previous one should be used for the current one, right? I cannot exclude the previous one in any way. What if I were to, okay, I know that I can skip some, right? What if I skip one pair at a time, right? Hmm. Okay, what if I do something like this? I have a pair. Let's say that, okay, let's say that we already have our answer somehow. Maybe I am trying to consider a dynamic programming approach here. I'm trying to find an optimal overlapping subproblem here. So let's say that you have like n such pairs and you have answer for, so say you have n plus 1 such pairs and you have answers for f of n. Okay, say you have a function n that returns the optimal length for n such pairs. Can I express n plus 1? Okay, say n is some x value. Now, what is f of n plus 1? Like, what happens if in this entire example I add one more pair? Say this is what I have, and now I just add another pair which I will call so I know 1 से 2 एक कुछ तो है, 3 से 4 एक कुछ तो है, and okay, this is actually a better example because I can add in out of order pairs as well. So suppose this is the pair that I had, and I know the longest length for this is like 3, so f of n, f of 3 is 3 for example, and suppose I add in another pair, let's just call it 4, 5 is good, uh, let's just call this like 8 and 9, and let's just say that we added a pair for 6, 7, right? What if we add this? Now if I'm adding this, what options do I have? Say I know that the previous length of chain was uh, 3. I know the previous length was f of n. When I add this new chain, I can see that if this was a part, if this was a valid part of this chain, if this was, if you were able to fit this properly somewhere in this chain, then my answer would have been f of n plus 1. So it's either you're selecting this or you're not selecting this, right? Okay, so you're either selecting this. If you do end up selecting this, you're just getting this, right? Does it make sense to not select this? It does not, right? It does not, right? So if this is immediately getting added in here, then it says that okay, I'm selecting. Okay, how about this? Instead of interpreting f of 3 as length for all these three elements, I can say the max length till the third position, I could say. What is the optimal length till this, I could say. Now what can somehow be a part that includes 3, like I know the answer till 3 is something, and if I say that hey, this gotta go in this, then I can add it plus 1. However, say that 3 is not something that I want to check out. What if I want to check out something before 3? What if I want to check out this f of 2? Like, what if I do f of n minus 1 plus 1? Like, I will keep checking for all the previous values where uh, I can use this in my chain, and I will add it. Like, so if f of n minus 2 plus 1 is what I'm doing, then it means that this thing in combination with n minus 2, like if the longest chain that was formed till f of n minus 1 was some value y, and this also fits in there, then I can say, okay, this is just plus 1. And this essentially would go on till, so this is gonna be n squared still. So it may take me n log n to just sort this, and then n squared to just do this. It's not dp because I'm not essentially effectively using this, but I'm gonna try to code some answer rather than doing nothing, right? So let's just say pairs dot sort. This should sort my pairs, right? And let's just say that my f is say 0 times length of pairs, and say f of 0 is say 1, right? For I in range of 1 to len of f, we wanna essentially keep filling the max value at f of I. So I can say that f of I is gonna be equal to max of, hold on, okay, so it's gonna be max of so can I make a case for not selecting the current pair at all? No, I always want to select the current pair because I'm evaluating the answer at my current pair. So it's going to be like, okay, 1 plus uh, max of interesting. So I can just say that since I'm doing max of fn minus 1, fn minus 2, and so on, so it's essentially doing a max of whatever pairs that I had previously, right? That's kind of weird. That's kind of wild, I would say. Then it doesn't that mean that every passing number I will keep getting? Okay, so I need to essentially ensure that if I am selecting that pair, if I'm selecting that pair, it has to fit the criteria. If I'm adding this to a chain, that then it has to follow the criteria for my pair, right? It can't just randomly get selected. It has to be like depending on the criteria, right? So this thing over here is gonna be is this gonna be like pairs? Okay, this thing's gonna be f of j if uh, pairs j 0. Okay, so I will just say that my current pair is gonna be AB, right? And there's gonna be another pair that is CD. And okay, so current pair is gonna be CD, the previous pair is gonna be AB. So I just gotta be like, okay, C, the previous pairs that I'm considering, so their B1 should be less than pairs of I 0. Else 0 for j in range, right? J in range I minus 1 minus 1 minus 1. So it's gonna iterate in the back direction. So f of j, we select if the the jth pair's right is less than the current pair's start, then it's a valid link. This is again n time complexity. This is again n, so it's n squared. This is not too good, but and we finally return a max of f of I. So this would be one way, I would say, n log n and then n squared, and then this is n, so the whole thing is by n squared. Is there any issue? Like, I know this is suboptimal. I think there can be like a much better way to do this, but I'm just gonna quickly try to uh, see if there's anything wrong. This is good. Len of pairs, 1 is good. What happens if my pairs are empty? So if, okay, let's just handle that. If len pairs is 0, you return a 0 because there's nothing to do. If you just have 1, then that essentially counts. If len pairs, does this handle it? Like f of 1 is 0, so it's like 1. This already handles it, so from 1 to len of 1, it's gonna be empty, so this max of fi, max of f, my bad, this was a mistake, so f of I, f of j. So let's run this and see if this kind of gives any sort of expected result. So this works as we expected it to work, irrespective of its order. Now the thing is, can we reduce this somehow? That's the optimization that you want to do. Let's actually add maybe a test case, right? uh, I don't want to add like a test case, like we had this test case. So okay, we have already exceeded our time. Okay, cool, we have exceeded the time. So technically, our interviewers would not be happy with this solution because it's suboptimal, but we gotta figure out a suboptimal, we gotta try to find a more optimal solution. Is there a way? So I know this is n squared. Now a way to actually make n squared, bring n squared to n, is there a way? So I know that this is where I'm doing like a maxing, and this max requires me to iterate through all my previous answers. Now let's say that I only had an eye on the immediate previous uh, answer, like if I did not have to go through the previous one, what would that mean, right? Because if I have a new link at n plus 1, if I had a new link at n plus 1, it would mean that that n plus 1 link should always be matched with all other links, right? Can I ever have a case where I can skip checking a link with all other links? Like, I know that my links are sorted, and if there are links behind it which are smaller than my current one, is there a case that I can make that, hey, I don't want to view my current, like this pair of 6 and 7, for example, right? Like it has come in, and I say do not want to compare it with all other links, right? Like I'm building my link one by one in n squared time complexity. But is there a way to, okay, so I know that my n is just 1,000. I know that it's like 1,000 is a pretty small number. There ain't much here doing with this. I'm just gonna try to submit and see if what is the performance that I get, or even if it like passes all test cases. Okay, so it's like beats 34%. It's not like the fastest, but there is someone here who has done it in like so ours is 1,000 milliseconds. We need to get to 192 milliseconds. So this is like very bad. This n square is pretty bad. So let's see. Say I change my dynamic programming model. Again, maybe being stuck on dynamic programming itself is a bad idea. maybe sorting itself was like a pretty shitty idea. Like, what if I don't have to sort? Like, what if I don't sort at all, right? uh, if I don't sort this, is there a smarter way to do this? Is there a linear time complexity that I can do? Okay, let's just say that n log n is sorting and I don't want to exceed n log n. Let's just say that I have a sorted uh, chain array for now, and if I can somehow use this information to, okay, so what if I assume that the largest length of the chain is the full array length, and my job is to systematically eliminate pairs that uh, do not fit in this array. Like, what if that's a hypothesis that I make, that this, for example, I say the chain length is 3, and then I do an iteration which just tries to get rid of chains, like get rid of pairs that cannot be properly put into a link, right? Is there any merit in, like, is this the only kind of pair that I can like eliminate, like a pair where the ends or the start end of one pair with start end of another pair is like matching? If so, for example, like if I say that, okay, I see a pair with uh if I find a pair, for example, where if I find two pairs where either their starts or either their ends are overlapping, can I form something with it? I know the only condition is B should be less than C, right? So let's do a thought experiment. I know that only B should be less than C. Can I perhaps say that I have a pair where A, B, and C, D, where I have B less than C. This is like, say, followed, and A equals D. Can I ever have a pair like this, right? We know that left is always going to be less than right, so we know that A has to be less than B, and we know B is less than C, and we know D is greater than A. So this pair can never happen, right? This pair can never happen. So if I want to eliminate links, I'm essentially, I can just assume that my entire length of pairs can make a link, and I'm just eliminating like bad links. Like, I know for a fact now that this observation where A is greater than, okay, okay, let's see, let's just say not possible, like this is not possible. Can I ever have a something of this sort, like B is greater than C, right? B is greater than C, sure. And can I ever have a case where uh, can I ever have a case where A and C are matching, for example? Can I ever have a pair, for example, okay, this is not yet possible, but what if I have a pair like B is greater than C, so I know uh, say 4 is greater than 2. Now can I have 2 here and say 5 here, right? Right. I know this cannot form a chain. This is not allowed to form a chain, but if I'm given these two sort of pairs, which one do I pick? Or are these pairs equivalent? Is my question. Like, I have these pairs, I have these two possible pairs in my uh, like array, and I want to decide if I want to use this or this in my construction of my chain. Now, is there a argument that I can make where I say that, hey, I want to use one pair over the other, and suppose there is a pair called 4 6 something, cool, and there's a pair called 4 6 again. Okay, so there's a pair called 4 6. Can I ever form this? I can't form this also. The eliminating both of these is kind of straightforward because I can't use these at all. But if I have a pair, say, which is like 6 7, right? 6 7, oopsie, 6 7. So I know I gotta eliminate this one. In this case, I kind of like I kind of eliminate this one and form a pair with this one. So okay, I have, say, these pairs now. I don't know if this is a valid pair, but I'm just assuming this is like a pair that I have. I can use this and this, and I can say I have a pair of two. I can use this and say I have a pair of two. I can use this and not this and not this. So now I can use this and this to form a chain, this and this to form a chain. When I come to something like this, right? Ideally, it says that it means that I should be eliminating this, but it also means that I can't use this, right? It means that I can't use this one or this one. So it's definite that I gotta get rid of this pair. What if I had this, for example, 3? What if I had 3? Then I could use this with this and or this with this or this with this with this. No, sorry, sir. Would have used this and this. So okay, so if one of them shares boundary with others, right? Say I keep a track of all the scene values for now. Say I've seen 2 and I've seen 4. I look at this and I say, hey, I have something that starts with 2 again and ends with 4. Which one do I use? Like, is there a case that I can make where not using 2 and 4 and using 2 and 5 instead gives me a longer chain? That's what I'm trying to think. Like, the way to construct this would be 2 and 4 would combine with some n chains, and if I say that I increase that interval between to form like a larger pair, I could argue that since the interval is larger, it runs more into the risk of colliding with some of the chains that I've already seen, so I should give it a lower priority. So if I have two pairs which have the same start point, right? If I have two pairs which have the same start point, then I can say that, hey, I will look into a hash map and I'll see what is the lowest minimum uh, interval that I have for it. And I say that, hey, I will ignore this. Okay, I will create a heuristic h1, uh, ignore pair if a, okay, left eye is seen and right eye greater than seen right. So I keep like a pair. I'll say like, hey, you know what? I will just ignore the pair because I could be like, oh hey, I have a pair which is 2 7, or I could say I have a pair like 2 6, and I try to use 2 6 with 2 6 7, and it doesn't work out because I have to eliminate this. But if I use this, right, 2 5, let's say 6 7, and let's say, and this is a good example because if I had 2 6, if I started with 2 6, I could not pick this, I could pick this, I could not pick this, but I could pick this. But if I started with this, I could pick this, this, and this. So it should be 3 instead of 2. So whatever is the minimum thing is the one that I want to pick, right? So of course I will sort it, right? Of course I will sort it. Sorting is gonna take n log n. It's gonna take n log n. So if I'm sorting it, I know that I'm getting it in this order and nothing else, right? So I can just say that, hey, if I've seen this already, like if I've seen this, if I've seen a pair starting with this, I can safely ignore this. I can just safely ignore this because no matter what happens, this is going to be sorted. So the sorting guarantees that I don't have to like go through this, and I can assure that anything greater than the current one is just gonna waste my time more. So I don't want it, right? Cool. Sorry. So I kind of get this now that I sorting is again. I'm assuming I'm starting with a sorted array. I'm trying to get rid of this loop as of now. Now I say that I have this starts in some scene array, and I like, hey, I've seen two. Now eliminating bad links, like I say, hey, I'm continuing on this. I don't want this. I don't want this link at all. Is it always the case that I will have to pick the first link? Like, can I make a case that there are going to be cases where you don't pick the first link and you still are doing much better than the next few links? Like, for example, if I have 2 5 and they then say I have something other than 2 5, like, I know all links are non overlapping. So if I pick the chain link of 2 5, can I go for the next few links, I guess? Hey, what the Sigma, bro? Hold on. My OBS has started malfunctioning again because the shitty bandwidth that I have in this place. Hold on. It's excellent, it's excellent. Okay, it's live. Yeah, whatever, bro. Yeah, sorry. So, coming up right now. My internet browser is not the best, I guess. But anyways, you know what? Like, we have wasted too much time on this. We should not be wasting too much time. So let's just look at solutions. There's a greedy one. Okay. Let's see. Time complexity is n log n for greedy. We're almost there, honestly. I think, like, if I were to like think of the greedy one, there is a way to do like n log n to just sort this, and then you gotta like how do you do that? Like, this is what you get rid of, and like if you were to be greedy about this and go to the next few pairs, you can eliminate pairs which were already for which the start was already seen, and the next few pairs, I think you can eliminate pairs which have an overlapping boundary, maybe? Like, if I've seen a pair, let's say that I pick a pair with the shortest interval first. Okay. Sort the pairs by the second element and traverse the list to construct the longest chain. Sure. And what does dynamic programming use? Dynamic uses n squared. Space complexity is n. Can you not do anything faster than n squared, I guess? Hold on. This is n log n. Hold on. So I know this. Shut the fuck up. Just give me the code, dude. So this is greedy. So they're just doing for pair in pairs. They took sorting first. That's fine. If current is less than the pair 0, then pair answer plus 1. That's fine, I guess. DP of I, you do the current one. Else one for this, and they just did the same thing. But that's. Hold on. So I solved this with 2D DP, which is n squared. Hold on. All. So greedy is the fastest one. n log n is the fastest one. So I gave him like a, so if I gave the interviewer n squared, they would be sort of disappointed, but I was very close to getting greedy one, right? Let's see. Shut the fuck up, dude. Give me just a decent greedy solution. So sorting is inevitable, it seems, right? And it makes sense why sorting is inevitable. So you're going through the pairs. If the current pair is less than the previous pair, okay, if the current is less than the previous pair 0, you just current is to its next. Okay, you're just doing straight up greedy. You don't care about anything else. You just sort it and then. Okay, so if I submit this again, maybe I can submit this a few times and see what is the. Usually, what happens is you kind of move up. You'll see I beat 35% of the people now. Okay, so the fastest solution has got to be like sorting and then n log n. Okay, so n log n was the fastest solution. Fine, I guess. I get it. I get it. Uh, let's just write this down in our sheet. This is a pretty decent code. Mistakes. No syntax errors, I guess. Uh, could not give the most optimal n log n n log n solution in time. Was able to formulate a DP solution. Okay, this is not the point of this column. What is the point of this column? Could not give the most optimal n log n solution in time. Why? Because spent too long. Okay, because used up all time in first solution, right? And which was in DP. After 20 min timer ended, wasted time in formulating greedy solution or n log n solution. So anyways, it worked, but it wasn't the most optimal, which is kind of bad. We should be faster than this eventually. But anyways, let's try a few more questions. Let's see. There's one. I'm gonna open a few more, I guess. Let's okay, let's start with the first one. Gotta start a timer. We gotta start a timer. Cool. So let's go here. Let's just do Q to I questions to the interviewer. Given the head of a singly linked list and the integer k, split the linked list into k consecutive linked list parts. The length of each part should be as equal as possible. No two parts should have a size difference more than 1. This may lead to some parts being null. Okay, fair. The parts should be in order of occurrence in input list. Parts occurring earlier should have greater size than or equal to the parts occurring later. Return an array of k parts. Okay, so I want to do this. So okay, so I get it. So I have a linked list where my k is much larger than the size of my linked list, and I do not know the end of my linked list right away. right? So that's okay, I guess. And I want to return linked lists rather than like a list of linked lists, right? It's gonna be a list of linked lists, okay? And cool. So questions to the interviewer. Uh, Max val of k. Okay. So let's just say range of k. That's gonna be like how big or small the k can be. Uh, num la in head. So do I care if my head has positive or negative numbers? No, I just need to divide it in several parts. I don't really care if it does not have parts, right? Okay, cool. I get it. I get it. Okay, I get it. I get it now. So this is done. This is pretty good. Um, okay, I think this makes sense to me. What else can I ask? No, that's it. That's all I need to ask. So I know the interviewer replies with, so 1 to 50. Num elements in head are 0 to 1000. And node vals, we don't care about node vals. Uh, don't care, honestly. But that's how I'll go about it. Next, so to solve the solution, what I have in mind is I'll maintain an empty list which I'll call my output, and I'll maintain a pointer called uh, start or something in my uh, which points to the head of my linked list, and then for uh, now what I will do is I know some of them have to be like null, like some of them have to be null. So I will keep iterating through my linked list till the linked list is not null, right? And for every element in my linked list, I will simply append it to my list. Uh, I'll simply append it to my list, and as soon as I hit an index of like my traversing through the linked list until the end, I will keep appending to I percentage k, essentially index of my list. So yeah, I mean that kind of should solve it. This should essentially just take n, where n is the number of nodes in my linked list. So I'm just gonna quickly start spin it out. So as I said, I'll create a node called output, and I'll just say list node of 0 and none for in range of k. So whatever this is. Now this is gonna start out by creating like a list of empty linked lists. So one of the questions is this like an empty linked list node, or is this like a none completely, right? Because okay, what if I actually just do none, right? Now I'll say LPTR is the linked list PTR, while LPTR, like while the linked list pointer is not none, right? I'll just say output PTR is gonna be 0 first of all. Now I will simply do output. Okay, if output and output PTR, oopsie, if output PTR is none, then uh, output output PTR equals LPTR, right? You just gotta be like, hey, this is this, else uh, I will just say I will just say, oh, of course, then it kind of means that I can't just have um, these linked list pointers. I kind of also have to have their respective heads if I'm doing that, right? I gotta like, uh, yeah, let's do that, right? Let's do that. Like, out PTR, okay, output LLPTR is gonna be output, right? And equals LPTR. Now ideally uh, I would not want to disturb one of them. So output PTR, for example, I'd want to modify this only once to capture the head. Captures the head, and everything else should just capture the next value, right? So dot next equals LPTR, and then uh, right. So this becomes its next essentially. So hold on. So my this is just gonna capture my head for the very first time, right? I got my head, and now my output pointer next is gonna point to like some LPTR, like whatever is the node in here, right? And then I'm wondering if there is some cleverer way. I don't want to like essentially modify the original list. I can essentially create like a new node, I guess. Right? Wouldn't that be better? Can I modify this, or I can modify the list, right? New node equals list node of val equals lptr dot val. That's it, right? That's what I want essentially. That I get the new pointer, and I say that hey, whatever output um linked list pointer was for this element was pointing to, uh, append the new node here and say that the current thing is now pointing to the very thing it was pointing to before, right? This is how it works. And we gotta implement the output ptr equals output ptr plus 1 percentage k, right? So it's gotta do like a round robin in general. Now at the end it's gonna result in, so I gotta return an output. So what's gonna happen, let's see. What's gonna happen is when my k is equal to 3, right? Let's just try to dry run this one, right? Let's just try to dry run this one. I have an output ptr, uh, I have this first, and these are all like nuns in there. So this is like none, 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 and so is this. So when I go in, I create a new node, right? I create a new node which is just gonna have 1 pointing to none. And now because the output ptr is 0, it's gonna say that this goes here and here, and my output ptr is output PTR, where is this? Right, my output PTR is essentially one percentage of 3, I guess, right? So right, so 1% is 3 is 1, so this is okay, so this moves to 1. So our LLPTR also needs to increment. This we forgot. So LLPTR equals LLPTR dot next, right? LLPTR essentially now moves to 2. LLPTR has moved to 2, and what has happened now is I have 2 and none in my new node, and what I've done uh, is this none? It is none, so it's just gonna do 2 and none, and similarly like 3 and none, right? This is how my LLPTR looks. Then after round robin, LLPTR becomes 0 and this becomes 4. Now 4 comes, and we go to the other branch where we say that output LLPTR's next it becomes the new node. So this is what I've done. This also becomes this. Um, okay, but I get it that this entire algorithm is wrong because we have to split it in consecutive parts rather than round robin parts, which is kind of a bummer because uh, and it's kind of a bummer because yeah, this is kind of a bummer because yeah, I think this would have worked if I had done it in like some sort of uh, yeah, the ooh, shit, I wasted so much 14 minutes almost in the wrong approach. So this solves it, but this does not solve it in the way they expect us to solve it, right? Like if k is 5, append 1, append 2, append 3. So I have to see all the nodes once, is what I would say. Like, what I'm thinking is I could perhaps traverse through the entire list and just separate out all these nodes into like a node that does not contain any of these. Uh, so suppose I just capture all of the nodes, right? Like I don't want to essentially worry about doing this. So I know the first ones have to have the largest amount of things, but if I okay, hold on, this is actually a very elegant problem because I kind of see something in follow this round robin approach, right? I see that I assign 1, 2 and 3, then 4, 5 and 6, then 7, 8 and then 10, and 10 essentially becomes the right, and that is essentially telling me that hey, you know what, you are. So the way I'm traversing this could essentially mean the allocation for the, because this although is gonna not have the right uh, order right now, I could essentially use round robin to figure out what are the optimal divisions, right? Like, oh dude, I'm just gonna modify my approach a little bit uh, and we're just gonna be like c nodes, right? So while ll pointer is there, I'm just gonna be like ll, hold on, so I know this, I know it needs to be divided into k parts, right? I know it needs to be divided into k parts. I'm just gonna be calling this like c nodes is this, and I'll just say c node at append of new node. This is what I'll say. Cool.